Okay, we're going to take a look at integrals that involve tangent and secant instead of just sine and cosine. The things that you need to know to be able to do this is that the derivative of tangent is secant squared, the derivative of secant is secant tan, and there's the Pythagorean identity 1 plus tangent squared equals secant squared. We're going to take the same ideas we did with sine and cosine in order to do this integral. If it wasn't apparent what we did, we pretty much isolated one of the derivatives. For sine, we isolated a cosine because that's the derivative. In this case, we're going to either isolate a secant squared or a secant tan. We want to choose based on what will leave an even power in the end after we isolate it. So let's take a look at this problem. I notice I have a secant to the fourth. So what I can do is I can pull out a secant squared, which will leave a secant squared, which is an even power, and that will allow me to use the Pythagorean identity. So let's go ahead and do that for this problem. So I'll have my secant squared, my tangent squared, and then my isolated secant squared x dx. What I'm going to do is with the remaining secant squared, I'm going to use the identity from above and turn everything into tangents, because then I can do a quick u sub. So secant squared can be replaced with a 1 plus tangent squared of x. So what I have in my integral is I have the 1 plus tan squared of x, I have the original tan squared of x, I have the secant squared of x that I pulled out, dx. Now this is just a quick u sub. I'm going to let u be tangent, and because of the way I chose things, du dx as secant squared x will cancel out the isolated part. So in u land, this is really 1 plus u squared times u squared du, and I can solve that easily. Okay, let's take a look at our second example. Again, we have the choice of isolating a secant tan or a secant squared. I want you to notice if you pull out a secant squared, you're going to be left with a secant to the first power, which is odd, and we can't use our identity. So this is a situation where it's actually better to pull out a secant tan and go from there. So I'm left with a secant squared x, notice that's even, and a tan squared x, also even, so that's good. And then don't forget your dx. So this time, since we chose secant tan, what we want to do is we want to turn everything into secant. So tangent, I'm going to change into secant squared x minus 1. Okay, so this integral looks like this, secant squared x, and then I have secant squared x minus 1, and then I have my isolated secant x tan x dx. And like before, I'm going to choose my u to be secant x, because then du dx will be secant x tangent x, which will cancel out. Okay, in this last example, what if you have a situation where you could go either way? You could either pull out a secant squared, which will still leave an even number, or you can pull out a secant tan, which will still leave an even number, and you can use the identity, in which case it turns out it doesn't matter which method you use.